Good morning, Algebra 2 students. Hope everybody's had a fabulous morning thus far. I'm excited about today's lesson. We're going to add on a little bit to the concept of a parabola, but I don't think you guys are going to have any trouble with this lesson whatsoever. Just a couple things to get down on your formula cards, and you'll be good to go. So today we're going to be talking about section 6.3 entitled Zeros and Inequalities. So it's two completely different concepts, but they kind of do go hand in hand. The inequalities, finding zeros, help you graph parabolas a whole lot easier. And they actually show you, we'll talk about what a root is, and it's actually an extremely important concept that you're going to need to know for the rest of Algebra 2. And for those of you that take pre-calculus, you'll definitely need to know this as well. So it's actually a very important lesson today, but it's actually not a super difficult concept. So let's go ahead and do a little bit of review here. State the vertex of each function. If you guys can recall, the vertex is always going to be equivalent to the number inside the parentheses, or the h is a way you can think about it. You probably have it written down somewhere like this. If you don't, you probably do want to write it down. The vertex is going to be equal to h and k. So whatever the h and k letters are that correspond with the equation that you also should have written down, the y equals x minus h squared plus k. That's where we get the h and k from. So if you know h and k, then you know the vertex. You know that coordinate, that where the parabola is going to start. And if you look at the first example right here on the slide, it's simply there is nothing next to x, so that would be 0, and then the k would be 7. Look at the second example here. Knowing this information, you see the number next to x, and you also see the k, so that's why that one is going to be 4 and 11. Again, it's minus h, so minus a minus 4 is a positive 4. Then you look at the third example there. This one's a little bit different. Here you have something next to the x, so we do it's in this section right here, the x minus h, so we do the opposite, so it'd be negative 2. And then since there's no k here, we know that the y coordinate for the vertex would be 0. So there's a very fast way to figure out the vertex if the equation is written in the vertex form. So state the domain and the range of the function here. We have some more information about domain and ranges. The domain are all real numbers for every parabola. It will always be all real numbers. The domain, again, is the limitation on the x. So there's no limit on any of the x values. So it's all real numbers. The domain is always going to be in relation to the k. This one is positive because it's a positive 5, so we know it's going up. Whenever it's going up, it's going to be greater than or equal to whatever k is. So k here is 3. So my range is y is greater than or equal to 3. That's review. Write this in vertex form. It's just some good practice here. We're not going to go through the process, but we would complete the square. You'd get it this form right here in vertex form, and you'd be able to let's take a look at something on that one real quick. Let's see if I can get back to it. Okay, vertex form. Just for sake of practice, what would the vertex be? If I said, guys, what's the vertex? You hopefully would be able to tell me. Well, that's h and k. All right, so if that's true, h here is the number next to x. We do the opposite of it. So that would be negative 3 halves. And then k is negative 11 halves. So that's where the vertex would be on this particular parabola. Okay, so the y-intercept of the quadratic function f of x is with the function ax squared plus bx plus c, the standard form of quadratic, is always 0 in c. So the y-intercept, whenever you see the term intercept, we've already talked about this in Algebra 1 with the y equals mx plus b. The y-intercept is called b. In a parabola, it's going to be whatever that number is on the very end, that constant, that coefficient usually. And it's always going to be 0 in c. So when you have to find the y-intercept, you literally are plugging 0 in for x. That's the way I always teach it, and I'd recommend you to learn it that way. To find the y-intercept, you plug 0 in for x, all the x's. And whatever you get for y is your y-intercept. The x-intercept, though, can be found by evaluating f of where f of x is equal to 0. and solving for x. So you basically just solve, you substitute 0 into the f of x part, and you solve that quadratic by, you can use factoring, completing the square, or even the quadratic formula in order to figure it all out. That's the roots. That's actually the concept when it comes to the zeros. The zero or root, it's the same term. It's just actually refers to two different things, but don't be too confused with it. It's going to be used interchangeably all throughout the year. To find the zero of a function, it's the value of which x, where f of x is equal to 0. So you plug 0 in for the f of x. A function's real number zeros are the x-coordinate and the graph on its x-intercepts. The term x-intercept here is synonymous with zeros and roots. It's where the parabola crosses the x-axis, hence why it's called the x-intercept, where it intercepts the x-axis. So here's what you guys are going to have to do. This is the first part of the lesson, okay? Find the y-intercept and the zeros for r of x equals 1/2 x squared plus 2x plus 2. Well, to be honest with you, the y-intercept will always be the easiest one to start with. To find the y-intercept, I literally just plug in 0 for x. I evaluate this to be 0. So I'll plug 0 in here, and I'll plug 0 in there. And that's exactly how you find the y-intercept. You guys can see on the screen here, that's exactly what I do. I plug 0 in for x, and sure enough, I get what that coefficient is at the very end, which is 2. So that tells me that the y-intercept is 2, which means the coordinate 0 and 2 is where this graph is going to cross the the y-axis, the y-intercept. So there it is. The y-intercept is 0 and 2 because x was 0. And we figured out that when x was 0, y was 2. So that's exactly how you find those coordinates. Okay, finding the x-intercepts can be a little bit more challenging. You got to plug in 0 for r of x. So literally, you could rewrite the equation. This portion right here is where I'm plugging in 0 for, if that helps. I just rewrite the equation. So I really have 1/2 x squared plus 2x plus 2 equals 0. So this is a quadratic. So the easiest method on this one is to go ahead and multiply everything by 2. That would get rid of that fraction. Always recommend to do that. If it was 1/3, we'd multiply everything times 3. If it was a weird fraction like 2/3, we'd multiply everything by 3/2. Whatever the inverse is, you just multiply everything by it. That'll get rid of that fraction. And here we can use a simple factoring method. We'd have products of 4. When you add them together, give you 4. That's x is 2 and x is 2. So you plug that in, and you say each one is equal. You set each one equal to 0 because we've got to use our product rule. Something times something equals 0. That means one of those somethings has to be 0. So we set them both equal to 0. And in this case, you get the same number. You get -2 or -2. So in this case, there's only one x-intercept. There's only one place this function crosses the x-axis. And we call that the 0. So the 0 is x equals -2. So that's the whole concept today. Let's try another one here. Find the y-intercept and the zeros for this particular parabola or this quadratic. It's already written in vertex form, which is kind of nice. So to find the y-intercept, you plug in 0 for x. So they do that, and they end up solving, and they get s of 0 to be 6. That means that this graph crosses the y-axis at 0 and 6. Again, to find the y-intercept, you plug 0 in for x. Write it down. You got to know that. To find the y-intercept, you plug 0 in for x. Then I need to find my zeros or my roots or my x-intercepts. Those are all three the same term. X-intercept, roots, and zeros are all the same term. So this is where you plug in 0, in this case, for s of x. You plug in 0 there, you end up with a quadratic. You move that over, you simply simplify it. You get x minus 1 quantity squared equals 4. And you guys know what to do at this point. Probably take the square root of both sides. You could have used the quadratic formula here. You could have completed the square. All of those methods would have worked for this one. So you get x minus 1 equals plus or minus 2. Because remember, anytime you take the square root of both sides, it's always plus or minus. So that gives you two answers for x. You move It skips a step here. I don't want to confuse you. You literally move that -1 over and get 1 plus or minus 2. So you say 1 plus 2. That gives you, it just deleted everything there. Sorry about that. That gives you x plus 1, which is, I'm sorry, 1 plus 2, which is 3. And then 1 minus 2, which would be -1. So those would be the zeros that it would give you. So there you go. That's how you find the zeros. Another example here, find the zeros of this. So I'm looking for the zeros, also called the x-intercepts. Don't forget that. So when you're solving for the x-intercepts, you plug 0 in for y. In this case, p of x. So you do that, substitute it in. I would go ahead and move the 6 over. You get -6. You see the negative on the left side of the equation. Go ahead and divide by that, and that makes that become a +6. So then hopefully you guys remember, I got to take the square root of both sides. So you get plus or minus the square root of 6. Move that 2 over, and it becomes -2 plus or minus the square root of 6. Now, thankfully, we don't have to graph this. It just says find the zeros. You found the 2 places this particular parabola crosses the x-axis. Now, keep in mind, this is just a tidbit of information. It's possible to have 3 different solutions here. I can have a parabola, maybe it starts there and it goes up this way. You see how this parabola crosses the x-axis there and the x-axis there? That means I'd have 2 answers for my zeros. Now sometimes though, you could have a parabola that maybe intersects the x-axis in one spot. Maybe it looks like this. Here you'd only have 1 zero or 1 x-intercept. And then of course it's possible to have no x-intercepts. Let's say I had this parabola. You guys can see here that this one does not cross the x-axis. So when you did all your work, let's say you did all this work over here and you got something that was undefined, well, that's perfectly acceptable. That just means that the parabola does not cross the x-axis. All right, so I think you guys got it. I'm going to move on to the second concept today. And the second concept on this lesson is graphing inequalities. It's still graphing the parabola just like you normally would, guys, so nothing changes here. So this should be a very simple process if you remember how to graph your parabolas. So here we have to graph this, so we need to write it in the vertex form. So we would go through that whole process, graph it. This case, they recommend to find the y-intercept just because it gives you a coordinate. We know we can also find the zeros by using the concept we just learned and applied. Again, to find the y-intercept, you plug 0 in for x. To solve for the x-intercepts, which are also called zeros, you plug in 0 for y. So you would do all that, you get this information, we could find the vertex. Once we write this in vertex form, you guys already know that. It would be 2 and 1 here. And then you guys can already see the kind of the shape of your parabola is taken. You're going to go ahead and graph this. And then we're going to use dashed lines. Again, hopefully y'all remember, why do we use dashed lines? Because it's just less than. It's not less than or equal to. If it's less than or greater than or equal to, less than and equal to or greater than or equal to, I should say, then it's going to be a solid line. But when it's just less than or it's just greater than, it's just going to be a dotted line. So they graph the dotted line there. That's what you guys see there on the screen. And then here I need a shader area. Remember when we dealt with inequalities with lines, we had a shade above or below the line? We're doing the same thing here. In this problem, it says less than. So we need to go ahead and shade below this parabola. So what you guys see on the screen there shaded in blue would be my answer. So technically, guys, the second part to the lesson is really just adding the inequality component. And y'all already remember how to do that. I'm very confident about that. Y'all remember how to shade in above or below a graph. Here it's just incorporating a parabola. So that's basically the concept there, guys. It's really not too bad. It's going to take a little bit of practice to get used to, but you got to remember the concepts. The key concepts, again, today were how to find the y-intercept and the x-intercept. Remember, the x-intercept is also called zeros or roots. It's all the same thing. To find the y-intercept, we literally plug in 0 for all of the x's. To find the x-intercept, zeros are roots, we plug in 0 for the y. And then you solve. Remember, on the zeros, you can get 2 answers, you can get 1 answer, or you can get no answers. That's also possible. All right, so you guys are going to be working on a couple of these problems just for practice. Make sure we got it. I think you can do this. It's just going to take, again, like a little bit of thinking through, but I think you guys really can do well on this. I want you guys to, let me see here. I want you guys just to do numbers 1 through 20. Numbers 1 through 20 on the homework set. You really got to learn how to make sure you remember how to complete the square and make sure you can write it in that vertex form. But if you can do that, you'll do fantastic on this lesson. So I hope this will give you some good practice, and I hope you guys will work hard on this. And I think if you do, you'll be very successful on this concept. Have a fantastic day. Look forward to seeing you guys on Thursday.